Injection attacks, including SQL injection, are one of the biggest risks to web applications on the internet today. Let's begin with our definition of what is a SQL injection, and I will also add to that attack. SQL injection is a method that takes advantage of how a server interacts or works with a back-end database server. And in a SQL injection attack, the server is tricked into passing SQL commands through the web application that then get processed and parsed and executed by the back-end database server. And some of the benefits of a successful attack could be that we're bypassing authentication or gaining access to information or data that we shouldn't have. That could also include changing data, which we shouldn't be able to change, which would impact the integrity or the reliability of that data. There's also the possibility of doing execution of code on the database server. So how would that be? If this is the database server in the company, and we've compromised it through a SQL injection attack, and now we can do remote commands on that device, we could have that internal server help us with reconnaissance and footprinting as we give it commands to go ahead and start sweeping the network or looking for devices and then reporting it back to us. So the play-by-play is we have Bill here on the internet, who's the attacker, who's interfacing with the web server, who has maliciously injected SQL statements as part of a form or at the URL and tricked the server into sending those over to the database, more specifically the database server, and then we have the possibility of all these elements happening, including having commands executed in the operating system of the database server that then can be leveraged to additionally compromise the entire network that that database server has access to. Now, regarding the methods and types of doing a SQL injection attack, they are going to vary a little bit depending on the type of database server that we're actually attacking through the SQL injection attack. And some commands in SQL that I want you to be aware of include a semicolon, which means it's the end of a SQL statement. So we could have statement 1 here, and then a semicolon, and then statement 2 here, a semicolon, and statement 3, etc. We can also use a single quote to represent the close of a SQL statement and then have additional commands after that. We can also add comments to SQL statements by having a double dash. And effectively, anything after that double dash, the system just sees, oh, as a comment, and it doesn't try to process. We can also have comments by doing a slash asterisk, and then having our comment, and then closing that with a asterisk slash. So this is the open, and this is the close regarding our comment. And that could come in handy if we want to have the system ignore part of a statement or part of a SQL command that we don't want it to process. And that's usually because if we have some additional stuff that's coming in, if we have the dash dash before it, the database server will simply ignore it as opposed to trying to process it and having a syntax error. So let's imagine that we have a login page at a web server. Let's say it's this web server right here, and this is Bill who's logged on or is about to log on, and it's asking for the username, and it's also asking for the password. Well, Bill, for his username, let's say his username is Bill, and let's say his password is P@SSWORD. But instead of just putting that, if Bill wanted to inject additional SQL statements, he could use the single quote right here, a space, and then have additional SQL commands. For example, he could say Bill, and they could have an or 1 equals 1. Now let me ask you a question regarding 1 equaling 1. How often is that going to be true? And the answer is, at least in the universe that we currently live in on this planet, it's always true. 1 equals 1. So in a web application that's not written well, if this web server passes as a SQL statement looking for the user Bill or 1 equaling 1, guess what? The answer is going to be true because 1 equals 1 is always true. Or the attacker could be a little creative and specify or 100 being greater than 1, which is also true, assuming those are both positive numbers. So one of the secrets of a SQL injection working is that we have an application working with the back-end relational database that is not paying attention or checking or validating data that the user is putting in. In addition here, we can put a dash dash at the end, and that means anything else that might be after that would not try to be parsed or processed by the database server. And that way, if there's some additional artifacts or issues that would cause an error message regarding an invalid query or the syntax being not exactly right, the dash dash says, hey, don't worry about anything after the dash dash. They're just comments. And the reason it's being done here is because Bill is hacking. Now, hopefully Bill is not doing this with his real username and password. Otherwise, that might be fairly easy to check. For example, if you and I are looking at the log files for failed login attempts, and we notice regarding login attempts, we have users with a single open quote, and then a space and a 1 equals 1 dash dash. Or we see as failed login attempts the command drop table which is an attempt to delete completely a table in the database. Those are huge red flags that somebody is either attempting to or successfully doing SQL injection attacks against your web server that's interacting with the backend database. And it's not only a form, like a login form, where we'd have the ability or potential opportunity to do a SQL injection attack. We could also be in our browser, and on the site, if it's done a database search and sent a query, that URL could also indicate the actual query that's been sent. So if we see a query, we could also add the single open quote, a space, and then additional commands right there on the URL as we attempt to do SQL injection to add additional commands with the intent or the hope that the web server passes those commands onto the database server on the back end. So there's three basic types of SQL injection. We have error-based, union-based, union referring to a SQL command, and the third is a blind. And here's the basic essence behind each of them. With an error-based SQL injection attack, if the syntax that's been sent to the database server isn't correct, it's going to go ahead and feed us back an error. So for example, if we're Bill, the user at a web page, we might get an entire page filled with details regarding that error. That might also reveal the type of database that's being used on the back end, how the syntax was wrong, where it was wrong. And that information can be useful for the attacker as they hone their skills and determine, first of all, that yes, there is a SQL injection vulnerability. And secondly, how then can they go ahead and further take advantage of it? And again, it's because the error-based method is allowing that feedback from the database server to be communicated all the way back to the user. And by the way, that's a mistake. That's a programming mistake from the code for the web application that's allowing that to happen. With a union-based attack, the intended result from the database server is sent back, as well as the results from our own SQL statements. So an example of that would be piggybacking the queries that we want to run along with the queries that the web server application intended to run based on the code. And the reason this can be so powerful is because as we make those requests, the database server just thinks it's the web server with whatever rights the web server has. So if accidentally the web server has been given full rights, read and write to everything in the database, and is also susceptible to a SQL injection attack, that means the attacker has pretty much unfettered access to the entire database. Now, if an application is well written and is not feeding back the information to the user, there is also the option of a blind attack. Effectively, we have to kind of guess to see whether or not the commands that we're adding and injecting are being successfully implemented at the database. And the question may come up, well, how the heck do we know if they were successful? And one of the options is to use a time-sensitive statement. For example, we can make a request, and as part of that request, we can set a delay. And then when it completes and there's a response, if the delay happened, we know that the command that we injected was successful. If there's no delay, we can assume that the additional SQL commands didn't take effect. Another option for determining whether or not the attack was successful is if we issue a command like drop table. With a request to drop a specific table, if that was successful, basically that table should not be usable by anybody. And so our normal functionality relating to that table should completely not only be destroyed for us, the user, the attacker in this example, as well as every other user that's relying on that table. And even if we're doing a blind attack, we could also just experiment with results. For example, we could do Boolean logic. So we could send statements that equate to true or false and then take a look at the results based on those commands. So if we compare a response page based on a true statement or a false statement and they're different, we can infer that our SQL injection is having some effect. Again, it's a lot tougher if we don't have error pages that are more obvious, but it's still an option that we can use. Now, in reality, it's very unlikely that an attacker or hacker is going to be sitting in a browser doing all these attacks manually. Instead, they're going to use automated tools. And some of those tools might include things like Burp Suite, which is pretty cool. What the attacker can do is the attacker can set his proxy to go to the Burp Suite server, which could be running on the same machine. And then as he interacts with the website, all that traffic is going through Burp Suite. And then in Burp Suite, before the actual request goes out to the web server, he can modify it. And not just modify it once, he can have hundreds or thousands of different options regarding some part of the string that he's sending, some part of the request, and then have Burp Suite just automate right through it and then gather the results. And using automation tools are the key to success in both the discovery and the enumeration of web apps that have SQL injection vulnerabilities or risks. And if we put in Bill with a single open quote right after it and we sent it, if the application is written correctly, it may come back and say, hey, usernames are not allowed to have these various characters, and never even bother the backend database because it knew it was bogus. So one of the big solutions to SQL injection is to doing data sanitization, verification by the application of any values that the user is putting in. And we could use regular expressions to validate the criteria of how long a username should be, the characters that are either accepted or not accepted. And if we stop it at the web server and we never allow a SQL injection and the extra commands to go back to the backend database, that's the perfect place to go ahead and stop it from happening, is right at the application, doing sanity checks regarding the data that the user is putting in. An absolutely great resource to learn more about SQL injection and the risks of it and how to solve it, I would refer you to OWASP. And it's owasp.org. And if you do a search for testing for SQL injection, you can use site:/owasp.org, it'll lead you to this document. And while we're looking here at the table of contents for this document, it's got detection techniques on how you can find out whether or not a site is susceptible to a SQL injection attack. It also goes into more detail regarding union and error-based and Boolean exploitation. It also has a section on evasive techniques that attackers might use so they are not discovered, even by an intrusion detection system that otherwise is there to help identify and stop the attacker's request from coming in. And if we continue to scroll down, it has examples of how SQL injection can help identify or fingerprint the actual database that's in use. And then once the attacker knows the exact database, they can go ahead and start using commands specific for that database. Because it may be Microsoft SQL Server or Oracle or MySQL or something else. And there are going to be variations of SQL commands that work specifically for a specific vendor's database. It also has some alternate expressions that can be used if a person is trying to evade an IPS. For example, if the IPS is looking for specific strings, which are looking for OR 1 equals 1, the OR 20 is greater than 1, and the OR 2 is between 3 and 1 are both also going to be true every time. Another automated tool is called HAVIJ, which is basically a graphical user interface. You plug in the site, or rather the hacker would plug in the site that they want to go ahead and test and compromise, and this would do most of the work for them. There's also a boatload of commercial products that could be used as well. And if we go over to hackthisSite.org, one of their advertisers is called NetSparker. And if we go to NetSparker, it is a commercial product. We could buy it or a person could download the demo. And this is an amazing product. You put in the URL, it'll go through, it'll walk through the entire site and analyze, first of all, if it's susceptible to SQL injection, and secondly, it'll start using the SQL injection techniques to fingerprint the database, identify what it is. And if that site is susceptible to SQL injection, it can determine the tables involved, the fields in those tables, and extract the data from that database all with a few mouse clicks. And on older implementations of Microsoft SQL Server, they had this feature called XP_CMD shell, which refers to an extended stored procedure on the database server. And if it's enabled, we can issue operating system commands directly into the Windows command shell on the database server running SQL Server. So for many years, this is off by default, but if it's on, the attacker has now that much more capability of issuing commands to the database server wherever it happens to be sitting. For example, maybe we're going to do ping requests or start scanning the network and getting these results back to the attacker, all through the use of SQL statements going through a poorly defined and poorly written web application. So what can be done to reduce the risk of a SQL injection attack? And most of it is going to be in the application itself. Now, ideally, if we have Bill out here or the attacker on the internet, what we could do is we could have our firewall. Now that firewall also may be the termination point for SSL. So if Bill's actually going to the server, perhaps we terminate the SSL session at the firewall so the firewall can decrypt the session and actually have the raw data for analysis. And then perhaps we send that data over to a web application firewall for analysis. And that web application firewall /IDS/IPS, IDS standing for Intrusion Detection System, IPS standing for Intrusion Prevention System, and maybe all that feature is integrated into this firewall as well, depending on the vendor. We could then analyze that traffic before it ever hits the server, looking for anything malicious that the user is putting in. Now, if these devices determine that the content that the user is sending over is not malicious, we can then go ahead and forward it over to the web server. And it's in the application on the web server that it should be validating the size, the type of data, and the content. And we can do that with whitelisting or blacklisting or both. And we can use things like regular expressions to identify the constraints that the data that the user is putting in, the constraints that it has to live within. And that way the application can say, whoa, 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 this is the character we're not allowing, like the single open quote, or a double dash, or two @ signs that are next to each other, or anything else that would be suspicious as far as not being a legitimate user doing legitimate requests. And the question is, well, Keith, if we're doing all the work in the application, why do we need the front-end firewalls, IDS, IPS sitting there as well? And the answer is multiple layers of defense. We don't want to have all of our eggs in one basket. We want to make sure they have multiple checkpoints along the way to protect our data and our infrastructure. So regarding size, type, and content, we'd want to be looking for, are we allowing for spaces or tabs or hexadecimal values? And then if that request got by the front-end firewall and also got by the application that's doing the inspection, then the server could go ahead and make the request to the database server on the back end. There's also specifics in how that request should be written. So instead of just taking the value, for example, as raw data and sending it to the database server, perhaps we assign that as a variable, and then that variable is called and then sent over to the internal server, which is giving us yet another layer of abstraction or separation between the user and the database server. We could also leverage stored procedures, which also could help if well written. So if any requests came that were outside of those stored procedures, we could have the database server say, sorry, we've got stored procedures for those, use them. We'd also want to verify for security reasons that this web application server only has the rights that it absolutely needs, the rule of least privilege when it's accessing the database. That way, if there is a compromise, the attacker then will be at the same limitations that the server has. So he won't be able to, for example, drop every table in the database if the server doesn't have those rights. And that's yet another example of doing defense in depth, multiple checks along the way, so that if there is a breach, we're mitigating or reducing the overall risk and impact of that attack. In this nugget, we've taken a look at some of the types and methods used as part of a SQL injection attack. I hope this has been informative for you, and I'd like to thank you for viewing.